Okay, ladies and gentlemen, dear students and followers of the Richmond School, today we're going to talk about solving exponential equations and what the equation is that and how we solve the exponential equation and what's the difference between the simple linear equation and exponential equations. Alright, let's get started our lesson. Okay guys, first of all, today is a plan, what we will do in this lesson. So, first, students will be able to solve exponential equation with the same base. Today we're going to learn how to solve the simple exponential equation with the same base, and we will try to solve more complicated as well today. The second one, students will be able to solve exponential equation with unlike bases. It means that we will today solve the same base and with the different bases as well, and we'll practice more today as well. Okay, the second the second slide is going to be about the properties of the linear exponential equations. Okay, first of all, as you can see, the first of all that we have. Okay, guys, look, first of all, as you can see, there is a solving exponential equations with the same base. We're going to start our lesson with the same base. All right, first of all, the purpose of equation for exponential equations. What kind of property it has compared with other equations? First, two powers with the same positive base, b, where b is not equal to 1 are equal if and only if their exponents are equal. Okay, guys, look here to the example. 2x equal to 2 into the fifth exponent. Alright, as you can see here, the 5, there is a base are 2 and the base there is a 2. It means they are the same, alright? And I'm going to show you, okay? This is and this is are they same, am I right? The 2 and 2. And then it means the bases are the same. Alright, in this case, if you think about the equation, when the left, right, and right sides, they should be equal, am I right? And that's why we can eliminate the bases, yes, easily, we can eliminate it, and then the exponents can be just reduced, like a x equal to just 5. Alright, and then it's going to be our answer if you substitute instead of the x your answers, and then it's just going to give you 2 in a fifth exponent. Alright, no, just sorry, to the 5th exponent is going to be equal to 2 to the, no, sorry, just getting 2 to the 5th exponent. Okay, they are the same. Okay, then let's move. Equal to 5 we can easily solve by just getting the 1 to the right side with the inverse sign, okay? And then it's going to be equal to just 4. Okay, let's go to the second example for our exponential equation, guys. Alright, first of all, 6 is equal to 6 to the exponent of 2x minus 3. Alright, as you know, to the x there is a 1 power. When there is a bases are equal, we can easily eliminate the bases. So, and then we got what? 1 equal to 2x minus 3. And then, as you know, we can minus 3 transport to the left side with the inverse sign. And then it's going to be 2x equal to just 4. And then if you divide both sides to 2, yes, we will divide it, then x equal to just 2. Sorry. Then the x will be equal to just 2. Okay, guys, so alright, was a basis of the solving exponential equation with the same basis. Let's move to the third slide, okay? Alright, this is our solution. So x equal to 2 and x equal to 4. Alright, and there is as well the third example. Okay, as you know as well, there is the same basis. It means 10 here, there is a 10. So 10 and 10 are eliminated, they're cancelled out. So there we have only exponents. That exponents is equal to what? Just 3x equal to, so guys, sorry. Okay, let's do one more time. Okay, when there is a left side and right side, they are equal. We can, as I said, you cancelled the bases. Then we got what? 3x is equal to 2x plus 3. So in this case, if we move 2x to the left side, yes, then it's going to be 3x minus 2x. Okay, it's 2. And then just we have what on the right side? Only 3. In this case, x will equal to just only 3. It is our answer. Okay, guys, let's move to the third slides, what we have here. Okay, so alright guys, I'm going to give you time for this solution. Please take the paper, just a sample of paper, and just one pencil, pen, it doesn't matter, and try to solve in the home. It's like a homework is going to be, alright? And when you solve it, please submit your answers with taking the photo, or you can just write to the comments, okay, what you got your answers, and try to do it as well, okay? But we will just move to the next slide, okay? Alright, guys, students, and let's move to our next exercise, the next topic, the next section. It is with unlike basis. Okay, it's a little bit different because we will need to come up and we need to make sure that left side and right side should be equal. This will be more difficult rather than compared with the first hour exercises. Okay, guys, let's look to the one example. Solving exponential equation with unlike basis. To solve some exponential equation, you must first rewrite each side of the equation using the same base. So our first goal, our main goal, yeah, to make left side should be equal to the right side. Yes, are they equal now? They are not equal. Our task is to make the left side and right side should be equal, like a 5x equal to 5th to the third exponent, alright? And then there are left side and right side now, are they equal? Yes, they are. And then we can easily cancel out the bases, and we got here that x equal to just 3, alright? Let's look to the second example, okay? So, sorry. So, if you can see, the 4 and 2 they are not the same. Yes, so 4 we can represent as a 2 to the second power, isn't it? Therefore it will be 4. So in this case the exponent of 2 multiplied to x, and we got what? 2 in exponent of 2x. Alright, and then it's equal to 2 to the exponent of x minus 3. Now the left side and right side, they are equal, so it's our achievement. Then we can easily cancel the exponent. Then we got what? 2x is equal to x minus 3, and then x we will move to the left side with the inverse sign. Yes, it is plus here. So in this case, it will move, and then it's going to be equal to x equal to minus 3. Okay, it's going to be equal to minus 3. Okay, it was not a difficult one, but let's revise again. Alright guys, in the exponential equation has two types. First type, it's with the same basis, and the second one with unlike basis. To solve this same basis, it is super easy because we will have the same what? Arguments, yes? Like here, 3 and 3. So it's not difficult one, and just we need to cancel out the exponent and take our exponent to the base, and that's it. Okay, this we had the second as well types, which called unlike basis. Okay, to solve this one, what should we do? In this case, we should in the unlike basis, our task is to make sure that the left side, yes, sorry, the left side and right side, they should be equal. Okay, if they are not, it's not possible to solve. In this case, it's equal, then we will cancel out and take the exponent to the base. Okay, as well as this example, 9 is equal to x plus 2 is equal to 27 to the x exponent, alright? First of all, as you can see, the 9 and 27, they are not the same, but we can simplify. How we can simplify? 9, it's just 3 to the second power, alright? So, this 27 27. So 27 we can represent as a what? As a 3 to the third one. Okay, so in this case, since the bases are not same, we can write 27 as a power of same numbers, power of 3. Yes, we got this. Alright, let's move. And then, as you can see, the 9 represents 3 to 2 and 27 as 3 to the third exponent. And we will just multiply the exponents, yes. This one multiplied to this one. And this is the same one, alright? Then we will move So, and then when we had a multiplication of the exponent, that we got a what? 3 to the 2x plus 4 is equal to 3 to the 3x. When the bases are the equal, we can cancel easily, and then we got the same, just simple linear equation. X to the left side and the numbers to the right side with the inverse sign. Okay guys, this is the same, the homework is going to be for you, okay, to solve, but let me just give you one example how to solve one of them. Okay, let's take the middle one, what we have here. 9 to the 2x and equal to 3 to the x minus 6, okay? Alright, first of all, as I told you, the 9 and 3 they completely different, they are not the same. So 9 we can represent as 3 to the second power. So in this case, what we have? We will have 3, 2, and with a scope of 2x, yes? And then it will equal to 3 then it's equal to 3 sorry 3x minus 6. Now when we will just multiply to 2 to the 2x, will give you what? It's just multiplication, okay? Exponent, this is a rule. A n in exponent of what? B, yes? The exponents will, what they will do? They will be multiplied. Alright, then we will what have? A n multiplied to b. Okay? Alright, in this case it's going to be given what? 3 to the 4x, okay, is equal to 3x minus 6. They are cancelled. Okay, then we will have what? 4x is equal to, then we will equal to okay, sorry. Okay, then we will equal to that x equal to minus 6. It's 6. Alright, dear students, dear maths learners, let's go. Now we will solve more exponential equations on like basis. Okay, let's look one example for more difficult one. To solve some exponential equations, you must first rewrite each side of the equation with the same base. It's a rule which we told, yeah, before. Alright, let's look to this one example. Okay. 1 over an exponent of x is equal to what? Is equal to x, right? Okay, as you can see, the left side and right side, they are not equal. Our task is to make the exponents, they should be equal. Alright. First of all, let's look to this example. 1 over 2. Okay, guys, sorry. 1 over 2. Okay, how do you think 1 over 2? How we can just simplify it? As you can see, was one formula. 1 over 2 we can write like 2 in exponent of minus 1. It was a formula like this. A so sorry, just get some wrong answers. Okay, look guys, we're going to use 1 over 2 like this. 1 over 2, it is like a 2 minus 1. Okay, it's a formula. Where it comes from? Okay, we had a one formula which told us like a minus 1, it is equal to 1 over a. Okay, it is our formula. Okay, we will use this formula to rewrite our expression 1 over 2. Okay, we will rewrite our expressions 1 over 2x like this. It's going to be what? It's going to be equal to 2 minus 1x, as I told you guys before, that 1 over 2 we can express like a 2 minus 1, and there we had the exponent of x, all right? And the 4 we represented like a 2 in exponent of 2, right? Then the 1 minus 1 is multiplied 1 minus 1 is multiplied to x, and we got minus x, and then is equal to 2 to the exponent of 2. As you can see now, there we had the same basis, so 2 and 2 they automatically cancel out, that we have a minus x is equal to just 2, and when we divide to minus 1, so x is will equal to minus 2. Okay, so this is our answer is going to be. Okay, let's continue. Okay, let's look to the second example to this one. 4x plus 1 is equal to 1 over 1 divided to 68. All right, since the bases are not the same, you can write 4 and 1 over 1 over 64 as a power of the same number. All right, as you can see, guys, 1 over 64. Yes, how we can write it actually? Let's get started. The 64 we can represent as okay, let me get from the another application. Okay, that is not so convenient to use it. Okay, let's do this one. Okay, like a 1 over 1 over 64. How we can represent? We can represent like a 1 over 64. It is what? It is 4 to the third. 4 to the third is going to give you 64, right? It's going to be 4 to the third exponent. It's just 3. Okay, in this case, then it then is equal to what? We can represent is like with our formula, like a formula a minus 1. It's equal to what? Is equal to 1 over a. So in this case, using our this formula, what it gives? It's going to give us the formula which is equal to 4 minus 3. Yes, okay. Okay, in this case, let's move to our presentation, and then in this case, what we have here. Okay, let's just skip it quickly. So look to the solution that, as I told you, that 4x plus 1 it's going to give you like equal to 4 to the minus 3, right? So in this case, just there is a 4, and on the right side there is a 4, and there we had easily cancel out 4 and 4. Then we got to get what? X plus 1 is equal to minus 3, and then it's just the ordinary simplification. We're going to get x minus 4. Okay, guys, let's now finish our lesson. Today was a trial lesson. It was my experimental lesson to teach you mathematics in English. Okay, I hope that everyone this lesson was useful, even just 1% or 2% for everyone. Next lessons we're going to make that English lesson, mathematics, and and other subjects as well, and then it's going to be in Russian, Uzbek, and other languages as well. Okay, I hope that this lesson is just suitable for you to watch at home and get some useful idea and knowledge from that extra material. What's more, I will upload more resources to my Telegram official channel, to the Richmond School. Then you can easily just go online, you can solve to your notebook, and then you can submit to me personally. Then I will check it. All right. First of all, thank you for your attention, guys. And if you have a kind of any comments, any suggestions, any offers, I'm so curious. I would like to please to get your comments to the in Instagram, in YouTube, in Telegram. Don't be shy. Write everything that you like, that you don't like, and something that we should change, something we'd like to add, something new. And I would like to change everything and make your this online lesson more convenient and more comfortable. Was our first lesson, online lesson. Okay, I hope everything was fine, and don't be strict. So this today I'm the same. I just try to learn new methodology, techniques, how to make online lesson. Thank you for your attention, and then we will see you on next Sunday. Thank you very much.